Lesson 1.8, Exponents. You'll remember exponents from lesson 1.4. She was our queen in the order of operations, meaning that exponents come second after grouping symbols. In math, there are a lot of shortcut notations that indicate various operations or symbols for different functions, things of that nature. Multiplication is actually a shortcut that was developed to deal with repeated addition. 3 times 5 is either 3 being added together 5 times or 5 being added together 3 times. And that's fine if it's short like this, but what if you wanted to multiply 140, or rather add 140 together 231 times? You didn't want to write that out, so multiplication was developed to deal with things like that. Exponents were developed for a similar reason, except instead of representing repeated addition, exponents were developed to represent repeated multiplication. So instead of having to write 5 times 5 times 5 times 5 times 5 times 5, we can just write 5 to the 6th. That's a lot shorter. So let's break this down a little bit. If you see this kind of notation, the number on the right that's smaller is the exponent, and the number on the left that's larger is the base. The exponent tells us how many times we have to multiply the base. So 4 squared is 4 times 4, that's twice, which equals 16. We were already familiar with squares, but an exponent can be any number, so can the base. 3 times 5 is going to be to multiply 3 by itself 5 times, which will give us 243. 6 to the third is to multiply 6 by itself 3 times, which will give us 216. 2 to the 10th is to multiply 2 by itself 10 times, which would give us 1024. The thing to remember is that you multiply the base, the number on the bottom, by itself as many times as the exponent says. 2 to the 10th is 10 twos, not 2 times 10. If you're using a calculator, there are a few buttons for exponents. Some calculators have an X with a small y, others have a Y with a small x, and some use what's called a caret. In either case, you'll enter the base, then you'll press that button, then you'll enter the exponent, and then you'll press enter, and that will give you your answer. Exponents with fractions. Now if I have 1/4 to the power of 3, that's the same thing as multiplying 1/4 times 1/4 times 1/4, which will give me 1/64. Another way to look at that, 1/4 to the third is the same thing as if I distribute this exponent to the 1 and to the 4. So I'll get 1 to the third over 4 to the third, which will give me 1/64. 2 to the 5th, 2 over 5 to the 5th, that's 2/5 times itself 5 times, which would give me 32 over 3125. Or again, I can distribute this exponent to both the 2 and the 5, which will give me 2 to the 5th over 5 to the 5th, which is 32 over 3125. Last example, improper fractions are the same. 7/2 squared is 7/2 times 7/2, which is 49/4. Or I can distribute that exponent to the 7 and to the 2 and have 7 squared over 2 squared, which is 49/4. Now negative exponents. Negative exponents are illegal in math, unless you're scientific notation. That's the only time negative exponents are allowed. When a negative exponent appears, what we do is we take the reciprocal of the number. So to simplify a negative exponent, I have 4 to the -2, and as I mentioned before, exponents are illegal, and so since they're illegal, we throw them in the basement and make them positive. So 4 to the negative 2 is the same thing as 1 over 4 squared, which gives me 1 over 16. If the exponent is already in the basement, and it's negative, 1 over 3 to the negative 4, we bring it up top. 1 over 3 to the negative 4 is 3 to the positive 4, which is 81. And if we have two negative exponents, 5 to the negative 3 over 6 to the negative 2, they switch places. This becomes 6 squared over 5 to the third, which gives me 36 over 125. And this is true with any negative exponent. You switch sides of the fractions. So if it's on top, you put it in the bottom. If it's in the bottom, you put it on top. We can also have exponents themselves that are fractions. If a fraction is an exponent, it indicates a root. So 16 to the 1/2 is a square root. Like this. And the square root of 16 is 4. 16 to the 1/3 is known as a cube root, which looks like this. See the little 3 right here? The cube root of 27. Cube roots occur when you have an exponent of 3. 3 to the third is 3 times 3 times 3, which is 27. So the cube root of 27 is 3. Right now we're only going to have squares and cube roots, but exponents could be any fraction, and those will be dealt with in future math courses.